Hi, my name is Zhang Jiqing. I am from FTMK, UTM Malacca, BITC S1G1 Group 2.
Hi, my name is Nur Anissa Minti Onong. I am FTMK student from BITC 1 Group 2.
Hi, my name is Nur Sakina Alia student. I am FTMK student BITC. I'm from Group 2.
Hello everyone, I'm Halim Hossein from FTMK BITC S1G1. Okay, what is MIPS? MIPS architecture is a reduced instruction set computer or RISC. Smaller number of instructions that use a uniform instruction encoding format designed for high-speed implementation. On this video, we create a program to be run in QtSpin which is allow user to input 10 random numbers. This program should be able to display first the number that have been sorted in ascending order. Second, sum of the entered numbers. Third, the average of the entered number. And last, we have to calculate median value for the numbers entered.
In this program, I'm going to explain how to sort the number in ascending order using MIPS assembly language. First, I'm going to explain about variable declaration. .data is the assembler directive. Array :.space 40 means that the array is stored with 40 bytes of space in memory. We use 40 because an integer requires 4 bytes of storage, thus 10 integers use 40 bytes. Then the code in this field line are used to store the string into memory. The string are the output that we want to print out later on. Before we start with the main function, we need to write these two directives. Then we only proceed to the main function. In MIPS, hash is used to start a command. ORI register T0, ORI register T10, ORI register S10 means that we initialize register T0, T1 to 0 and set them as counter I and J. We also initialize the register S1 to 0 and set it to the sum. LI register V0 for LA register A0 from syscall. This is the code we use to print out the prompt string immediately. It is also called a syscall function. The usage of syscall is for printing values to a monitor console or reading values from keyboard service. The type of function can be distinguished by the value here. LA register S0 array means that we will load the array into register S0. Then we will proceed to the looping part. We will loop to input 10 integers. LI register V05 syscall. This is a syscall function that reads the integers of user input. SW register V00. This is a code to store the user input from register V0 into 0 address of register S0. ADDI register S04 means that we add our array by 4 to move the array pointer. ADDI register T01 means that we add our counter I by 1. Branch not equal register T010 loop means that if register T0 is not equal to 10, it will loop until register T0 becomes 10. Thus, the program will repeat to loop until counter I is equal to 10. LA register S0 array means that we load the array into register S0 again to reset our array position to default. Sub register T0 by T0 means that we will reset our counter I back to 0 so that we can use it again after that. Next, we will do the sorting of number in ascending order. In sort1 function, branch on equal register T1 9 sort2 means that if register T1, which set as counter J, is equal to 9, it will go to sort2 function. If counter J don't hold any values yet at first, the program will skip this code. LW register T2 0, LW register T3 4. This means that it will load array with address 0 of register S0 into register T2, and the following code also means that it will load arrays with address 4 of register S0 into register T3. ADDI register S0 by 4, ADDI register T1 by 1. This means that we will add array by 4 to move the array pointer and counter J by 1. Branch less than register T2, register T3, short 1 means that if the register T2 is less than register T3, it will go back to the short 1 function. This code is used to compare register T2 and register T3. The one which is smaller will move to the front and the greater ones remains. SW register T2 0, SW register T3 minus 4 means that the register T2 will store the value with address 0 in array, and register T3 will store the value with address minus 4 in array. Branch on not equal to register T1 9 short 1 means that if the counter J is not equal to 9, it will go back to short 1 function until J becomes 9. When the register T0 becomes 9, it will go to the short 2 function. Then we will proceed to the short 2. LA register S0 array is used to reset back the array to default. The code in these two lines is used to compare the value of counter I and the value of counter J. So the value of I is equal to value of counter J at here. Branch not equal register T0 9 short 2. This means that when the counter J is equal to 9, it will proceed to the syscall function at the next line, which will print out the ascending string. LA register S0 array sub register T0 by T0 means that we will reset array pointer to default and counter I to 0. Next, we will go to the short result function. LI register V0 1 LW register A00 syscall. This is the syscall function used to print out the array that have been sorted in ascending order. LI register V0 by 4 LA register A0 space syscall. This is syscall function that is used to print out the spacing. ADDI register S0 by 4 ADDI register T0 by 1. This is the used to move the array pointer by 1 and increase the counter I by 1. Branch on not equal register T0 10 short result. That means that if the counter I is not equal to 10, it will go to the short result function. LA register S0 array sub register T0 by T0 means that we will reset the counter I to 0 and set back the array pointer to default.
Okay, now we will move to the sum. First, you load the array, and then you will add the array and sum to get sum. And then you increment update for the array and also increment update for the I, so that it will increase whenever you input the new number. And then the instruction will stop if I less than 10, then the sum will take the place. Okay, and then this instruction is get the print out sum from. Okay, from this we can get the we can display the sum when we run it. Okay, this is to reset I equal to 0, and then This instruction is to set sum as array.
For the average, the formula for the average is sum divided by 10. We use MFLO for register T5 for the question, and we use MFHI as register 4 for the remainder. Next, we move register T5 to A0, and then we print out the quotient, and then we call out the dot or the decimal point, and then we move register T4 to A0, and we print out the remainder. Next, we have the result, and the average we declare as register S2.
Okay, we move to part of median. First, we have load array into register S1. So that we have to print out median text. Next, to calculate a median value, we have to load number array in T5 and T6. Okay, add T5 and T6, which is equal to register T1. T1 indicate as total sum. Then, as we know, the formula if median is add two numbers and divide by 2. After we get a summation of two numbers, which is T1, we have to divide by 2 that we have calculate at immediate 0 plus 2. Then the quotient we get, we move to register T5, and the remainder we move to T4. After that we move T5 to A0, which is to print out the quotient. While this part we print out the dot, and this part we print out the remainder. And this command shows the end of program. Okay, let's start check out the output of assembly code that we have done by running QtSpim. First, we open a file and we initialize and load file. We open the file that we have done. Then we run. Then we enter the 10 numbers. Then we get the ascending order is and the sum on enter numbers, average, and the median values. So thank you very much.